Hello. All right. Yeah, thanks everybody for coming for today's recitation. It's on, right? It's a paper writing workshop intended to help. It's more informative than educational, but yeah, for it helps outline what's expected for your final project. And the components that Bickshaw will want you to cover. So yeah, the purpose of the project is to help you show your understanding of deep learning. And so it's a written report describing original research results. And yeah, it should help communicate new scientific findings that you have as clearly as possible. So the paper includes, yeah, a statement about the problem or the question, a presentation of evidence, an assessment of the strengths and weaknesses of your presentation, and the conclusions. So yeah, you should begin your project by discussing your literature review or literature search, and that'll include things you find on Google Scholar, papers with code, for readings that are relevant to what your project is on. Yeah, you should use keywords to search for related works on the topic. And yeah, you want to decide what topic specifically you want to pursue for your project by reading about what other experiments people are doing. Yeah, and right, you want to generate ideas about how you'll be contributing to existing research and yeah, what you'll be doing with your teammates in the context of this project. So the standard format is you should have a title section, you should have a title and authors with an abstract section, introduction, lit, literature review, methods, results, discussion, and yeah, conclusion and future works with citations. And yeah, I'll pass it to.
Okay, so the title and authors part, try to use the fewest words possible to describe the contents of your paper with the title, and think about the keywords people might use to search for it on Google Scholar. You should capture the gist of the experiments and findings, and don't use any abbreviations. The authors, you can decide this early on. Whoever is writing the most typically gets listed first. So that's a easy way to see who's going to be doing the most of the writing early. For the abstract, it's a summary of the information in your final paper. So it's a mini version. It's much less technical. It still states the objective or scope, describes the methods, summarizes the results, and states the main conclusions. But it has no citations, and it should be short, one paragraph, 250 words or less. Usually, you could write this last after the paper is finished. And the introduction, it presents the nature and scope of the problem you're investigating. So make a clear problem statement with the data and objective explicitly defined. State your hypothesis and propose a solution. And to facilitate understanding, you should have a high-level diagram. And if you want to better articulate it, you can have a separate inference and training diagram if you feel that it's necessary. The terminology and basic methods in the intro should be defined at a high level. The literature review, Bickshaw likes to call it prior art. In most cases, your problem is not going to be new. It will have been thought of before and just may have a different application. So you're going to look for what the earlier solutions to your problem has been. How well did other researchers perform in the context of your objective? And how is your way of solving the problem different? So did you apply a state-of-the-art model from one domain to a different domain? Did you use a new loss to improve on an existing state-of-the-art result? Did you create a new data set and methodology that solves a novel problem? These are just questions you might think of to answer. It's important that you include the key ideas behind the papers that you cite in this section. And you can end the literature review by distinguishing yourself from everybody else.
Cool, thanks. Yeah, so for the proposed solution section or methodology, yeah, to write this section, we break it down into 3 components that, yeah, you should have clearly delineated in your paper, which is the higher level concepts, technical details, and implementation details. So the higher level stuff includes the information needed to understand how you're presenting the empirical evidence that's motivating your hypothesis. Why do you think your solution will work? What makes your problem challenging and important to solve? And yeah, for the technical details, you should write a detailed diagram that has the core components labeled and describe your methodology. And the math should also be formalized in this section. So all the variables should be clearly labeled. Any equations that you need to do your analysis, those should all be defined. Everything from accuracy to cross entropy loss, to F1 score, MSE, whatever you're using to solve your problem. In terms of implementation details, you have to explain the algorithms you're using with explicit definitions, an outline of any approximations or shortcuts you took, and you should provide enough detail that another researcher is able to replicate your study. A core part of the project is that you have to have a baseline, and everyone is required to have a baseline. And it's necessary to contextualize your proposed solutions with respect to prior work. And yeah, the baseline is an existing solution to the problem. It's a competitive solution, but it has room for improvement, which is the whole purpose of your paper, is to improve on this baseline. The entire goal is to demonstrate that you chose a valid baseline for your problem, that you created a novel and working solution to the problem, and how your solution performs relative to that baseline. And yeah, throughout this, you should be justifying why comparison of your approach to the baseline is necessary. In terms of the experimental validation, this section contains only facts, no analyses. The analyses are for the subsequent section. But it should be stated clearly so that the reader understands what you're doing. Yeah, in general, if your explanation's not clear, the reader will perceive that as you not knowing what you're talking about. And because we're doing peer review, students reviewing other students are particularly critical when it comes to lack of clarity. Yeah, so you'll need to explain your data in a way that the reader knows why you're using the data and why they're appropriate for your work. You need to explain high-level understanding of your results and why you get those results, including what you varied with the architecture and hyperparameters to show how or what did or didn't work. This is also referred to as a ablation study. In terms of analyses, you should write your experimental outcomes, and you'll be relating those directly to your original hypothesis. And yeah, they should answer the research question and hypotheses you presented in the introduction, discuss if your original hypotheses have been validated or invalidated, point out strengths and limitations of the study, and compare and contrast your work with the prior works. And that contextualization should be consistent with your motivation. And yeah, you should show the significance of your results that you observed in the experiment and present what relationships or generalizations you find in the results, and then discussing the theoretical or practical implications of your work. And yeah, I'll pass it off.
The last section for writing, the conclusions and future work. So summarize the evidence that you found. What did you conclude overall in your analyses? Did you solve the problem? And if not, what would be the way forward, in your opinion? What future works or developments are needed to improve your study? Some rules, if it's hard to read, you're gonna get a bad grade. So revise, edit. Use the present tense when you're referring to work that's already been published. So, and then the past tense when you're referring to your own study. If the method has previously been published, you should cite the reference. So here's a good example where it's a great description of demux, and then we have the citation here. At the bottom, not so good is if you just kind of refer to it and don't really explain where you got it from and what it's about. So this is pretty standard. References. We're using the APA format because it's a scientific paper. These are some examples if you get it from a book or a chapter of a book, journals, and a website. So you can Google this as well, but here's a few examples. Right. You can also search for papers that are written well by students like yourself. So these are a few examples of best paper awards from conferences, and just a few of many. So look out for what is expected of you. These have a similar structure to what Big Shaw is asking for.
Cool, thanks. And I'll end on, yeah, so I'm not going to read all these out, but yeah, these are some of the questions that will come up during grading and a peer review. And yeah, it'll go over everything from the theoretical to the practical implications of your work, and going over components necessary for clarity in terms of, are you explaining your empirical investigation? Are you defining everything that you're using? Are you connecting ideas to one another? And yeah, again, the purpose of the project is to show your understanding of deep learning. And it's not necessary that you beat state of the art. I've seen projects where students get a really good result, but have a very poor explanation, and they might get an average grade. And I've seen projects where students get absolutely horrible results, but they have a very clear explanation, and they're able to say why what they tried didn't work, and what they would do moving forward, or what they wish they would have done. And yeah, that's basically it. So I guess we'll open to questions on the project, if anyone has any. Yeah.
Say that again?
Yeah, so for the project proposal, yeah, so there's different types of ways to approach the project. Either you're, sometimes the TAs or a professor will propose a project, or someone from industry will propose a project. And for the proposal, and throughout the project, for the proposal and for the midterm, you're graded primarily by your TA mentor. And so you should focus on delivering what they would like to see. There are general suggestions, but yeah, if you're creating your own idea and it's not someone else's idea, then you should fall back on the outline that we give for the proposal specifically. And in the proposal, you should have a clearly defined question. The evaluation metric should be clear. The data necessary for the problem should be clear. And in reading the proposal, there shouldn't be any uncertainty as to what you're doing or if your project is viable. Yeah. Any other questions? Cool. So I guess I'll just go on a brief about, yeah, what makes a successful project. So yeah, I've seen a lot of projects, and usually the ones that do the best are ones that are very clearly and concretely scoped at the proposal stage. So if you don't know where you're going to get the data to solve your problem by the proposal, or if you don't know what models you'll use, or if you don't know what existing works are out there, you're going to have a hard time getting through the project. The ones that are most successful are ones where there's a concrete motivation, where there are examples of the approach you're using working on similar tasks, or for example, last semester I mentored projects on speech enhancement, and in the area of speech enhancement, there's a lot of models that are known to work on the deep noise suppression challenge, for example. And the unique aspect to the project was that we collected this new data source that had audio recorded over Zoom, and we're trying to see, can we improve Zoom audio quality? And yeah, in doing that, we're able to say, okay, we can just take these methods that we know work, but we're applying it to a very similar problem, but a completely new data set that, in the case of that project, we created ourselves. So yeah, that makes our solution unique in and of itself. If you're not creating or using a new data set, then yeah, it becomes more challenging. Right, like if you're working on ImageNet or MNIST, if you're running ResNet on MNIST, you'll probably get a not great grade because you're graded by your peers, right? And your peers, if they think you're cutting corners, when they themselves kind of had to tackle a pretty challenging problem, then yeah, it's not going to reflect well in your grades. But yeah, again, you don't have to have state-of-the-art results. That's one of the main issues, is students, they'll spend all the way until like the final week trying to get and improve their results. But at some point, you need to be okay with the results that you have and just focus on the writing and focus on clearly articulating and explaining what it is you're doing. If your results aren't great, why aren't they great? You just need to explain it to show your understanding of deep learning. And if there are things you want to try, but you don't have time to do, or you don't have the compute resources to do, yeah, just explaining those in your paper. And if your problem was hard, there are a lot of complexities that you'll experience that other people won't fully understand unless you state them explicitly. So like in the Zoom example, creating the data, the audio engineering involved, that was particularly challenging, even though we were able to get a good result. So yeah, any questions on how to decide on what project to do, what makes a good project, what not to do? Yeah.
So I may have missed this, we guys talked about it, but do we pick our own like TA mentor for the project? How does that work?
So TA mentors aren't assigned until after the proposal, unless you choose to work on a proposed project statement. Like for me, for example, I'll be proposing some projects related to speech enhancement. If there might be an interview process, but if you're chosen to work on that work, then yeah, you'd want to coordinate with me, and we'd go through what to have ready for the proposal. Otherwise, if you're making your own project idea, yeah, it makes more sense to, after your proposals are submitted, TAs are assigned depending on their interests. Maybe one's TAs focus more on vision versus another's focus on language versus another's focus on speech. And then, yeah, that matchmaking will happen. Yeah, cool. Any other questions?
Rickshaw will usually introduce professors who are interested in having students work on a.
Yeah, so I guess, yeah, we've had people from, right, TAs, other professors. We've had people from industry like NASA or Microsoft, and yeah, they come with some ideas. I'm a little biased. I think the TA suggestions, they come from a perspective where they've kind of been through the project before. They kind of know what's in scope. And yeah, there are a lot of good ideas that might be challenging to fit within a semester. But yeah, you don't want to underestimate, yeah, the compute requirements and the engineering that's involved to make your solution possible. And so, yeah, you want to look at the papers that are out there and see, okay, what's the compute that they use? And if you're training from scratch, if you're fine tuning, compute is not, it's still important, but it's not as expensive as setting up some completely different loss or framework to improve on an existing pre-trained model. So yeah, that's some stuff to think about. And if there aren't any more questions, we can just call it there. Cool. Thanks, everyone. Oh, okay, what's up? That's a good question. So yeah, they'll be released on a rolling basis as the ideas come in, but they'll be before the proposal deadline for sure. Yeah, right. And yeah, the proposal, it's a very rough, it doesn't need to be perfect. The midterm is where it gets a bit more rigorous. But yeah, depending on your TA mentor, what's expected for the proposal may vary. So like the students I mentor, I like to have it where the proposal, the stuff you write is also, you can just copy paste it to your final project. So there's no repeat work in terms of like literature review, explaining the problem, evaluation metrics. And yeah, you want to limit as much repeat work as possible, but yeah, it's up to you. Yeah.
Will we have more instruction on the project proposal of like what to write about, like more specifically, or like, I don't know, because the website from like project report example, that doesn't have project proposal example, or does that actually matter? We're just going to be a paragraph.
Yeah, so for the project proposal, you should have, right, a clear question. The data should be clear. Yeah, we'll be giving a more detailed outline. And yeah, which will be particularly helpful if there's not, yeah, a TA mentor or professor who's proposing the work.
Your final grade is not based on the proposal, but it gives the TAs an idea of what you'll be doing so that they can be grouped accordingly. Yeah, it's just to make sure that you're on track more than anything, yeah.
Yeah, so if you want TAs who are serious to be interested in your work, having a serious proposal is probably one of the best ways to get, yeah, someone who's interested in maybe making a publishable work. Cool, and that's about it. So, yeah. Yeah, and we'll put some more examples on Piazza of what good reports look like. Yeah. Cool. Thanks.
Thank you.
So
Any other questions?
That's about it.
Yeah.
Feel free to, do other stuff.